Model from Stellar Network. And we have Nathan from BlockCloud. So I'm not going to talk all night because you don't want to hear me the whole time. So I'm going to pass the mic to Kijo, who's going to tell more about what QuarkChain is doing right now. And
since it's a large small group, do you want the audience to introduce themselves as well?
Yes.
To make it more interactive?
Sure. We are of course very curious to what kind of people we have over here. So some hands in the air with regards to your background. For example, are there blockchain developers in the house? Please put your hands in the air if you're a blockchain developer. No. Who's full-time in crypto? Who works in crypto full-time? Interesting. Who is into DEF CON today? Who likes DEF CON today? Okay, great. What else? What else do we need to know demographic-wise? Is there someone who wants to say what's the main reason he joined this event and not one of the other events? Is there someone who wants to elaborate on that? Sure. Alexander.
Yeah, it's the only event on the list that is not related to Halloween, and it's something serious regarding to all the other events.
That's a nice compliment. Thank you very much. We're going to have fun too, but no Halloween over here. So, well, I'm dressed as an Arab. But it's a joke. That's a joke. Okay. Any other one? Someone else wants to elaborate on why they joined specifically this event, and if they're specifically more interested in perhaps QuarkChain, or BlockCloud? No? Sure. From Netherlands-Amsterdam.
Yeah, so I think it's very interesting how these projects are trying to solve scalability issues in space. And what we believe in as Netherlands-Amsterdam is that this is a fundamental problem that needs to be solved first before we start focusing on the additional layers of there. So that's why we are here to see how these projects are further progressing in space.
Thank you very much. Does anyone else want to add something? No? Okay. I think it's time to give the floor to Kisho. We're very excited to learn more about what you've done with QuarkChain the past couple of months. And we're also excited to do a Q&A afterwards. Everyone will get a chance to ask anything they want to Kisho. Okay, thank you very much.
Thank you. Hey, so everyone, my name is Chijo. I'm the founder and CEO of QuarkChain. So today I will give some presentation of the QuarkChain regarding what we have done in terms of QuarkChain 1.0 and what's the future of QuarkChain, which is QuarkChain 2.0 in the future. And so what is QuarkChain 1.0? Basically, QuarkChain is aimed to design to address the blockchain scalability problem. As we all know that blockchain right now is suffering from the scalability issues where the transactions are pretty slow. For example, Bitcoin has roughly 7 transactions per second, while Ethereum has roughly 15 transactions per second. So QuarkChain aims to address this to offer a decentralized, secure, and scalable blockchain so that we can offer more than 10,000, actually 100,000 transactions, on-chain transactions by employing a technology called horizontal scalability technologies. And so I will explain what is horizontal scalability later, but this is basically a core technology that employed by Google and Facebook in their basic data centers and to offer internet-wide user services. So we are basically a group of engineers from Google and Facebook who work on these structures at Google and Facebook and have extensive experience to know, for example, designing, implementing, debugging, optimizing, and maintaining these systems. So why the blockchain scalability problem is so difficult? Actually, this is a tricky one here, is that it's very hard to achieve the 3 major factors in a blockchain in terms of decentralization, security, and scalability. So if we suppose we just ignore decentralization, actually in the centralized world like Google and Facebook, the people already develop some software like Bigtable and Cassandra, which is able to deliver maybe millions or tens of millions transactions per second. For example, Bigtable is developed by Google, and Cassandra, which is backed by Facebook. And if we sacrifice like scalability, then Bitcoin is there right now. It's working pretty well. And suppose we sacrifice security, which we will talk more later, then we can employ multiple blockchain to offer kind of higher performance. However, for example, recently there are several blockchains like Bitcoin Go are being attacked because of the we call hash power dilution issue, which we already discussed more detail later. And so actually the scalability is also, before it becomes the problem of the decentralized world in blockchain, it is also a core problem in the centralized world, especially after the rise of the internet. So before the internet, rise of the internet, like in the year 2000, like people resort a kind of technology to address the scalability issues called vertical scalability. The basic idea is to add more expensive like devices to a single machine and to improve the performance. For example, I can add more faster CPUs to improve like calculation speed, and I can add more memory or disk to improve storage or better network adapters. There are a couple of companies that are famous in this area, like some Oracle, EMC, that are famous for their like workstation solutions, database solutions, or storage solutions. Now, however, after the rise of the internet, the user growth exponentially over time, and so using this kind of traditional vertical scalability will suffer from the performance limits because there are physical limits of these single machine devices. For example, we cannot have arbitrary fast CPU. The clock of CPU reaches some limits and cannot go further. And also, like for storage, if we put more storage in some limited spaces, then it will cause, like the cost will be grow exponentially high. So to address this problem, Google and Facebook, they developed a new way to address this problem we call horizontal scalability. So basic idea is to build a cluster of commodity PCs. Each of these commodity PC will be very cheap, but put them together and then run it in the data centers, and also build a software that manage all these machines and offering these services. They're able to achieve much higher performance. And so one famous system, like for example Google's Bigtable and Facebook's backed by Cassandra, is built on part of these ideas. And the core ideas called this horizontal scalability is called sharding. And now back to the decentralized world where we are facing these days. We believe it is following a similar trend that actually some like centralized world has been gone through, where we see the early stage that solutions to address the blockchain scalability problem is similar to what the vertical scalability looks like, which we call improving the single blockchain performance as the vertical scalability in the blockchain. So for example, like Litecoin, like there are two key parameters in a single blockchain to determine the performance. One is block size, another is block interval. So the Litecoin improved the Bitcoin performance by, for example, reduce the block interval from 10 minutes to 2.5 minutes, so you can claim 4 times performance improvement. And Bitcoin Cash reduced the basically increased block size from 1 megabyte of Bitcoin to, right now it's 32 megabytes and even more, so they can claim 32 megabytes, 32 times performance improvement. And however, those two parameters, similar like what we have seen in the centralized world, you cannot arbitrarily increase block size or decrease block interval because the physical limits of network propagation on these parameters. So the new vertical solutions, scalable solutions like, for example, Ethereum or like the EOS, they use the kind of technology to use new consensus, like EOS using DPoS to limit the number of the block users to 21, so the network size will be much smaller than Bitcoin, and so that the block interval can be reduced to further sub-seconds. And so, but suppose that in the future, after the school of 3 years and the blockchain become more and more popular, which we really believe in, then we believe all those vertical solutions will quickly hit its limit, especially when the user grows exponentially, similar like internet. So we need to resort in new solutions to address this problem, where we believe is the core horizontal scalability in blockchain, which is called blockchain sharding. So sharding, how it works, basically sharding, the idea is to partition the whole state to substates we call shards and process each state relatively independently. Take an example, for example, voting consensus. Like for example, in the United States voting, instead of I have a single voting box, we put this voting box to multiple places. Imagine these different places in kind of shards, and people just vote locally and put them together so that they can merge all the results and get final results. If we just use a single box, then we will definitely have a lot of performance issues because people need to take time to travel, take time to vote. But by partition these tasks to different locations, then we can achieve much better performance. And this is actually similar as idea of sharding by partition this system state to different shards and process them independently. And so there are several key challenges in the blockchain sharding. One is how to partition the ledger. So we know that in the blockchain, the ledger is kind of a kind-only log, where the log contains transactions, which a list of these transactions put it as a block and put it together. And how we are able to partition this system, the log and also system state, so that we are able to process this data more efficiently. And here we impose called big table-like state partitioning. Why? Because big table is first is pretty mature in centralized world, and second is that the big table and actually the ledger, the system state of the blockchain is essentially the same. They are also key value stores. And second is how to, suppose we have all these partition states, how we are able to drive each shard or storage state of each shard, and while we can ensure security. And here we propose called boson consensus, which is able to process all these shards and in parallel. And also the final question is how to enable interoperability and usability if we have multiple shards. And here we introduce called like a DH style cross-shard transactions, and we will discuss this in more details. And so first, how to partition states. So basically the idea is inspired by Google's big table, which is famous distributed key value store developed by Google. Actually, there's an interesting story regarding this Google's big table, saying, hey, the people asking the founders of the Google, they have what are the most regretful things that when they are in the early stage of Google. And the rumors says they publish these papers, like big table, too early, so that their competitors, like Yahoo, they build an ecosystem called Hadoop, which is built on top of Google's ideas, and we build all that system, now it become more famous. And so there's also corresponding Hadoop or Apache version called HBase, which for this big table, which is basically built on top of big table's paper. And why we are inspired by big table, meaning because they are both done in both of big table and also blockchain like states. They are essentially key value pairs. And so for key value pairs, then we can use some similar ideas that build already built in the big table and deploy it to improve the system performance more efficiently. Because there's also some experience and lessons has been already learned by those centralized companies. However, there's still major difference that makes it more complicated. So one is that we are more in decentralized world, and so we need to make sure that this state partitioning can work properly with proper consensus, and also have proper token economies to be able to work on it. And second is that in the blockchain, a lot of data are not being deleted, unlike in a big table, which the data can be assumed to be deleted. And so this major difference can help us to, one is make things more complicated. But simplified deletion model can make something more simple. And so here is the comparison of the QuarkChain and big table. I won't go to too much details in this table. Actually, you can read more context of this comparison by scanning the QR code, and which I will discuss this in details. But I'll just tell you that there are some similarities between these two, and why we are building on top of these principles. Okay, the next is basically consensus. So people know, like, for example, how to, like, since we have multiple shards, a simple way to drive these shards is basically just using multiple blockchains. And however, with multiple blockchains, this will hit an issues because some kind of called dilution issues here. Actually, even in Ethereum 2.0 and all these sharding projects, they have this kind of issue to be potentially kind of like block producers may be able to be diluted. Like, for example, suppose all the shards are being driven by hash powers, like using it to work, then this is called hash power dilution issue. For example, one famous hash algorithm is called EtherHash, where you can see that there are several blockchains that are now employing EtherHash to drive the network. And for Ethereum, right now, you have 216 terahash per second. While for the rest of the, for example, blockchains that use EtherHash will have much less. For example, Ethereum Classic has only 13 terahash per second. So this means that if all these blockchain, if they, for example, suppose we have 100 blockchain and using the same hash algorithm, then one of them will have at least, at most, 1 to the 100 hash powers. And to provide double spending attack will be much easier. And for example, for the EtherHash Classic, it only requires 6.1% of the Ethereum hash power so that people can perform a double spending attack on Ethereum Classic. And so this is kind of contrary to what it claims to be 51% attack. Because this hash algorithm is used in multiple places. And so suppose as long as the multiple blockchain using the same hash algorithm, there will be suffer from this hash power dilution issue, even for famous Ethereum Classic. And so to address this problem, we propose called boson consensus. So basically, our idea say, hey, for each block in the blockchain, it has two roles. One is to process transactions, as it includes a set of transactions. Another is basically to have insufficient hash power to protect these transactions. And so why don't we just separate these roles individually and make each blockchain to perform this role so that they are specialized in either security or transactions. That's how we come up with the two-layer blockchains. There's one layer blockchain called root chain, which basically is to offer securities by having more than 50% of the hash power of the network in the root chain. And we also have a list of sharding blockchains, which is focused to process transactions efficiently. What I define efficiently is that it can include more transactions with relatively less hash power. So right now the root chain runs for consensus, while the sharding blockchain runs root chain first consensus. And so with this, we can guarantee that any double spending attack on sharding blockchain must also attack the root blockchain. And there's also a QR code that has more discussion of this, why must also attack the root chain in details. So with this, we can, suppose we have the same hash power of the Ethereum network, EtherHash network, then we can organize those hash powers more, I would say, reasonable to both to balance the security and also the efficiency. So for example, if we have multiple blockchain using the same hash algorithm as I give an example of this theorem, then any double spending attack or even blackbox attack, it only requires 1 to 2n, where n is number of blockchains. And so they can perform double spending attack. And for example, Ethereum, Classic, or other blockchains can be easily attacked using this formula. And with Boson consensus, as long as they're put them together and under the same root chain, yeah, we are able to at least 25% of the hash power of the network to perform attack. Which means that in the Ethereum case sense, we require more than 50 terahash per second to perform the double spending attack, which is much stronger than the Ethereum Classic. And also, it has a sacrifice of blackbox attack, which is much less severe than the double spending attack. And for the interoperability, basically, we employ the ideas of DAG. Actually, QuarkChain itself, from another perspective, is a one-structure DAG, where each block, and I would say sharding blockchain block, has 2 hash pointers, similar to some DAG, but with different semantics. So with this DAG, actually a lot of DAG can be classified as a special case of blockchain by partition the ledger by the addresses instead of shard key, by putting shard key equals addresses. And so I will take one example of a famous DAG project called Nano as an example. So if we can put shard key as the addresses, and then they have several things. For example, all the transactions in Nano, because they will send from one address to another address, imagine from one blockchain to another blockchain, it's kind of always issue cross-shard transactions. Well, we are allowed to support both in-shard and cross-shard transactions by abstracting the shard key, and also we support smart contract, while the Nano, because this the state is quite distributed, so it does not support smart contract. Okay, so this is more technical overview of the blockchain, and a lot of technical details can for example, can be found in our Medium pages. Now from more engineering side, so we first, all these features I just mentioned already implemented in our code. And so we launched our first testnet on July the 7th, which have a distributed global-wide deployment with 250 shards and more than 6,000 nodes. And the peak performance TPS numbers we get is more than 40,000 transactions per second, which is roughly 1,000 times faster than Ethereum right now. And we also open source our code on September 17th, and with after around 8 months development. And we are also, with this open source code, I also have several achievements. And based on the open source code, right now we are holding a called TPS competitions, where everybody is able to use our open source code and run it to reproduce what we can get during our first testnet launch. Where right now the first number in the TPS can have more than 33,000 transactions per second, which is completely reproduced by our community members. And also we are going to have additional offer to our local community members during this time. If anybody is able to achieve better numbers than our current first place, because this is today is the last day of the TPS competition. So during this stage, anybody can beat these numbers, will be able to obtain the prize from a pool that has 1 BTC. And so feel free to join our community to ask any questions of these TPS competitions and how other people, what are the configurations and what kind of code they are using to produce this number. And we are also planning to launch our testnet 2.0 in this month, and then so that everybody is able to join the network and also be able to produce the block. And by producing the block, people are able to receive the mainnet tokens once the mainnet is launched. And we also support different consensus, different hash algorithms, both in Bitcoin's double shard 256 and also Etherhash. And we also have proposed our further algorithm to be more like ASIC resistant. We call all statistics-based kind of algorithms. And so we welcome everybody to join the network and mine the network and to collect the mainnet tokens. Okay, this is basically what we have done. And now we are discussing some brief features of QuarkChain 2.0 in the future. So besides scalability, I think another critical problems in blockchain is regarding flexibility, because like people takes time to, for example, improve blockchain. At Bitcoin, people it's got a long time to say how to, for example, improve the block size. And Ethereum also spent a long time for example, to create new features to like create a fork or supporting like proof of stake by Casper or Ethereum sharding. So we believe like using the sharding technology, we can make a lot of things much flexible. So they can easily incorporate it on like a consensus, virtual machines, or even token economies. So here is the list of the existing blockchain projects where they are in terms of virtual machine consensus and token economies, what they can do. And for the QuarkChain, so our goal is basically to have more flexible in terms of different shards, so that they can be able to incorporate different consensus or even like token economies. So why flexibility is so essential to next generation blockchains? And so one thing is that the blockchain has been growing so rapidly. Like a lot of things happen day by day in terms of virtual machines and consensus. So with this kind of this flexibility, we can easily to embrace these technologies by putting them as a new shards in the system. And we are also be able to use this system to support existing like for example, existing blockchains like Ethereum by using Ethereum virtual machines and account-based ledger. And in addition, we are proposing the idea called multi-native tokens. Basic idea is that right now Ethereum has two types of tokens. One is native token, another ERC20. For ERC20, there are a lot of restrictions. For example, people using to as a payment, there's a lot of complicated process, and also it's also very unfriendly as a transaction fee, and also cross transaction as quite limited. And with multi-native token, the whole ecosystem will have multi-native token. Each one will be served as first-class citizens, so that when you perform a payment, it only needs, for example, single step instead of multiple step, which imposed by ERC20. They can use it as directly as a transaction fee, so that like people who, while like an ERC20, a lot of times they may not be able to perform kind of transaction fee, and also, for example, it can be easily support scalable cross-chain transactions and also mining. And so the QuarkChain 2.0 is targets to provide more flexibility and scalability infrastructures to incorporate the latest blockchain innovations, and also we create a lot of like, for example, accommodate a lot of needs of like vertical domain blockchain, so that they don't need even to create their single blockchain at the risk of like security and other concerns. Okay. So this is the plan of the QuarkChain 2.0 from the technical side, and also I have to give a quick summaries of our ecosystems. So right now we have TTP's listing on Binance, and also we have more than like 10,000 global, actually more than 100,000 global communities. And we also have invested global-wise and have more than 15 projects that are working closely with us in different directions, including gaming, data information system, and also the chain sector. And so this is the most this is all of my presentation. So I would like to answer any questions. And also we have 50 questions.
To get a better perspective, could you maybe compare QuarkChain sharding with Ethereum sharding? It's easier to grasp and if you have something to compare with, like what is QuarkChain doing differently, or what are the trade-offs? What's good about Ethereum way of sharding? What's bad, and so on?
That's a good question. So first of all, QuarkChain sharding is already there. It's running in testnet. Well, Ethereum is still scheduled in next year. So from engineering perspective, we are running much faster. Mainly because we adopt some mature technologies that are already well proved by centralized world and tailor it for the decentralized world. And secondly is that Ethereum sharding, to my knowledge, they are dealing more complicated things. First of all, there's a need to backward compatible with Ethereum. That means there's additional burden you need to maintain backward compatibility. And we know that like Windows, when it supports 32-bit in the API from 16 bits 32, it put a lot of effort in order to backward compatible. So that's why Ethereum is more complicated task, sharding task than us. And also some technology features of Ethereum highly depends on other components, for example, Casper of their proof of stake implementation, which I think changes 3 or 4 times at least in this year. So you see Casper early design now, it changes a lot because it's not finalized yet. And for us, we adopt proof of work consensus, mainly because people complain it's energy not friendly. But we say, hey, if we can process a lot of transactions with this amount of hash powers, then things come efficiencies. And also there's also a lot of good properties of proof of work. Its security model is well defined. And like proof of stake of Casper, a lot of the security model, that there's a debate between Cardano. They are debating different security model because a lot of things are not being well started yet. And so I think Ethereum sharding a lot of parts that are still in the research stage. But while for us, according to our engineering experience, we know which things can be done because already something there, and which can be do it later, like QuarkChain 2.0 or 3.0. So we run much faster in this direction.
Okay, thank you.
Any other questions? Okay. Oh, another questions.
Yeah. The previous slide with the projects, you said in the past few months there were 50 projects. Yes. 50 projects that are built on QuarkChain. And how do you count these projects? Well, if I have a project, how do you count my project in this list?
Yeah, so basically these projects, we basically talk to them. For example, Sarah is part of our partners, and we talk with each other, and we have a conference. We discuss what kind of technology is, what's the problem it's going to solve. Sarah is going to solve off-chain, we are going to solve on-chain transactions, and then we discuss the details, read white papers, and then determine whether this is a good quality project, and then we then discuss how we are able to employ, for example, the platform sharding platform to address kind of user problems. And once we finalize, the team is solid and the solution is solid, then hey, let's sign a partnership. And this is not something we just put a logo. We must have this partnership signed together so that we can say, hey, we are going to work together and to address this problem on top of us.
Okay, so if we have a client, we work on his blockchain solution, and we want to use QuarkChain for this.
Yes.
What's the procedure? What should we do? How do we start in this?
So we have testnet, and testnet. So you can also set your testnet, but you can also use our testnet. And we also have our API documents documented, which is similar to Ethereum Web3, but with some enhancements. So we can use these things and to wrap. And also our testnet also support MetaMask as the interface to sign the transactions, and deploy the smart contracts. So a lot of things just using similar concept of Ethereum, but you can imagine like early version of Ethereum 2.0.
And as a procedure, okay, we have access to the API, to the testnet, and so on. As a procedure, how we would join and start working together?
Feel free to contact us, and then
Okay.
we can just assign some meeting for the talk.
Okay, thank you.
Thank you. Any other questions?
Cool. Yeah, thank you very much. Yeah, feel free to.
Audit, security audit.
Sorry?
You didn't say a word about security audit.
A security audit.
Yes.
Yeah, that's something that.
How far are you on this field?
Yeah. So right now we first have testnet 1.0, then which basically we verify the test ourselves. Actually, we have an internal QA team to doing all this work.
Yeah.
And then now in testnet 2.0, now everybody is able to join the network and see what's going on. And the next two stages that we are also going to hire third-party code review. Basically, we already have this list of these agencies to help us to review the code. And third is we have this bounty to welcome the hackers around the world to attack this network. And once everything said, everybody said, it looks like it's solid, but nobody can guarantee it's 100%.
When is this?
Mainnet.
When is this planned for security audits?
The plan?
The plan external security audits.
The plan is more about it depends on the stability of testnet 2.0.
Mhm.
Because at that point, when it's stable, we know that, okay, most of the features now running correctly, and now we can ask audit. Because the audit can help us to discover these actual issues. But if you start too early, then because a lot of issues can be discovered by ourselves, right? Yeah, so there are different stages for. Also, we actually consult several projects, because how they audit their code and how they are, for example, which agencies have good qualities. So we already have this list. But feel free to contact us if you have better ideas, or if you want to hack us and figure to let us know.
Just
And
a utility issue.
Yeah, I think this is common issues for everyone. And for example, like Bitcoin, like a few weeks ago, they have a bug, like be able to mine arbitrarily large size of Bitcoins and be fixed. So this is constantly efforts, not just like simple one-stop efforts. And
Yeah, the main issue right now, I took for one of my projects in the utility sector. In the utility sector, you can develop or implement blockchain only if it's secured and already audited. Otherwise, it's not mature enough to implement utility sector. So this is also an issue why this has not gone to main segment like water, electricity, and other energy sectors, because it needs to be